Welcome back, everybody. Ready for another deep dive?
Absolutely. Always ready to jump into the deep end.
Well, today we're going deep into quantum neural networks.
Oh, yeah. This is where things get really interesting. The intersection of quantum computing and AI. Lots of potential here.
So much potential. We've got a whole stack of research on this.
Looking forward to unpacking it all.
Me too.
Yeah.
Our mission today is to break it all down. Like what are the core concepts? What are the applications? And why is everyone making such a big deal about QNNs?
I think that blockchain thing really caught everyone's attention.
Yeah, one of the articles even mentions that QNNs could make blockchain technology basically unhackable.
That's a pretty bold claim, but it really speaks to the potential impact. We're talking about two fields that haven't always been closely linked. Quantum mechanics, with all its weirdness on the subatomic level.
Right, like its own set of rules.
And then, of course, artificial intelligence, which is all about mimicking and even surpassing human intelligence.
Powerful stuff. Combining these two could have some serious implications.
Absolutely, especially for problems that classical computers just struggle with.
Okay, so let's dive into the more technical stuff for a bit. These quantum neural networks, or QNNs, they're kind of like the neural networks we already know about, but instead of the normal bits, the zeros and ones, they use these things called qubits.
Exactly, and that's where the quantum magic comes in.
So can you break that down a bit for us? What exactly is a qubit?
A qubit is like a bit on steroids. Imagine a bit that could be both 0 and 1 at the same time. That's what we call superposition. It's like a coin spinning in the air. Until it lands, it's both heads and tails.
Wow, so each qubit is juggling possibilities. Okay, that makes sense. But then there's this whole other concept of entanglement. I always get tripped up on that one. It's like the qubits are linked in a way, right?
Exactly. Entanglement is this spooky action at a distance where qubits are interconnected and can influence each other instantaneously. Doesn't matter how far apart they are. Regular bits, they can't do that. It's like they have this secret communication channel.
Okay, so with these quantum capabilities, these QNNs can process information much faster.
Way faster. Exponentially faster than even our most powerful supercomputers.
Wow, that's a game changer. So they can tackle problems that are just impossible for classical computers. Like, for example, I read about how QNNs could be used to search massive data sets for drug discovery.
That's a great example. Imagine trying to find a needle in a haystack, but you can search the whole haystack at once.
Oh, I see. So you're talking about quantum algorithms like Grover's algorithm.
Exactly. Grover's algorithm uses quantum mechanics to search through data exponentially faster than any classical algorithm.
Can you break down how Grover's algorithm works in like a simple way?
Sure, imagine you have a huge phone book with millions of names. You need to find a specific phone number. A classical algorithm would have to go through each entry one by one. But Grover's algorithm, using quantum principles, can search all the entries simultaneously. It's a massive speedup.
Okay, I'm starting to get it. That's how QNNs could really change the game for drug discovery. But how exactly would that work in practice? What real-world problems could they solve?
Well, take drug discovery, for instance. It's super time-consuming and expensive to design new drugs. QNNs could change that. We could potentially simulate the complex interactions of molecules at the quantum level.
So instead of physically creating and testing drugs in a lab, we could do it virtually.
Exactly. QNNs could analyze huge data sets of molecular structures and identify potential drug candidates much faster and with incredible accuracy. We could potentially cure diseases that currently have no cure.
That's amazing. And what about that blockchain example you mentioned earlier?
Right, blockchain security is based on super complex math problems, problems that are hard for even the most powerful computers to crack. But with quantum computers becoming more powerful, some worry that those blockchains might not be as secure anymore.
Because quantum computers could potentially break the encryption.
Exactly. Yeah. But QNNs, they can help us out. We could use them to create new types of encryption methods, specifically designed to be resistant to attacks from quantum computers. We might actually see blockchain technology become completely unhackable.
So QNNs could revolutionize cryptography and make blockchain technology even more secure. I also read about their potential for solving optimization problems.
Oh yeah, that's a big one. Optimization problems are everywhere. Logistics, finance, even things like traffic flow. And QNNs could really help here.
How so?
Well, they can leverage quantum phenomena like quantum tunneling to find the best solutions much more efficiently than classical methods.
Okay, now quantum tunneling, that sounds pretty sci-fi. Can you explain what that is?
Imagine you have a ball and you want to get it over a hill. Classically, it needs enough energy to climb all the way up and over. But in the quantum world, That ball might just tunnel straight through the hill, even if it doesn't have enough energy to go over. It's like taking a shortcut.
So QNNs can kind of find shortcuts to the best solutions, even for really complex problems.
Exactly. And that's a big part of the excitement around them. We're talking about solving problems in a fraction of the time it would take traditional computers.
That's incredible. So much potential.
It really highlights the power of quantum mechanics when applied to these kinds of challenges.
Mind-blowing stuff, really. But let's move on a bit. The research we're looking at mentions some really cool results from experiments with QNNs. They actually ran them on real quantum hardware.
Yeah, this isn't just theoretical anymore. Researchers are running these experiments on platforms like IBM Quantum Experience and Rigetti Forest. These are cloud-based systems where you can actually test QNN algorithms on real quantum hardware.
So it's not just simulations, we're seeing these things work in the real world.
Exactly. And the early results are really promising. It shows we're heading in the right direction. Like these QNNs could actually live up to all the hype.
That's amazing. But I'm guessing there are still some challenges, right? What are some of the hurdles researchers are facing, when it comes to developing and actually using QNNs on a bigger scale?
Well, one of the biggest challenges is definitely scalability. The quantum computers we have now are still pretty small. They have a limited number of qubits. To really unlock the power of QNNs, we need to build much larger and more stable quantum computers.
So it's a hardware issue. What about the algorithms themselves? Are there challenges there too?
Absolutely. We need to develop more advanced quantum algorithms that are, specifically made for QNNs. Algorithms that can really harness the unique properties of quantum mechanics, like, superposition and entanglement to get even faster results.
So it's a two-pronged approach then. We need better hardware and better algorithms. The research also talks about the importance of collaboration, like between quantum physicists and AI researchers. Why is that so important for this field?
You need both sides of the coin, right? You've got the quantum physicists who have this deep understanding of the quantum world. And then you have the AI researchers. They're the experts in designing and training neural networks. You bring these two groups together and boom, you get this incredible synergy, leading to all sorts of breakthroughs.
Like a dream team, bringing together the best of both worlds to create something amazing. So much potential. But I think it's also important to talk about the downsides. Are there any risks or ethical concerns with QNNs?
With any powerful technology, we always have to be careful about how it's used. We need to be very careful that QNNs aren't misused and that they're developed with ethics in mind.
It's not just about the science, it's about making sure this tech is used for good, for the benefit of everyone.
Exactly. We need to have these conversations now to make sure we're guiding the development of QNNs in a responsible and ethical way.
Well said. So where do we go from here? What's the future hold for QNNs?
I think the future is incredibly exciting. We're going to see QNNs being used to solve more and more real-world problems, leading to breakthroughs in areas like medicine, material science, and artificial intelligence. It's really just the beginning.
What about you personally? What are you most excited to see in the future of QNNs?
Honestly, the unknown. We're just scratching the surface of what's possible with this technology. I think there are going to be discoveries and applications that we haven't even thought of yet.
That's the beauty of it all, right? The thrill of the unknown and all those potential groundbreaking discoveries that could change the world as we know it.
Exactly. And that's something I hope you keep in mind as you continue to explore this topic. The world of QNNs is full of possibilities. So stay curious, keep exploring, and who knows, maybe you'll be the one to make the next big breakthrough.
It really is a field that sparks the imagination. So, as we wrap up our deep dive into quantum neural networks, what are some of the key takeaways our listeners should keep in mind?
Well, I think the biggest thing to remember is that QNNs represent a totally new approach to computing. They use these mind-blowing principles of quantum mechanics to solve problems in ways that classical computers just can't.
Like we're entering a whole new era, the possibilities seem endless.
Exactly. And with that comes huge potential for breakthroughs. In fields like medicine, material science, AI, we talked about how QNNs could revolutionize drug discovery, make cryptography unbreakable, even design materials with properties we can only dream of right now.
It's wild to think about. But as we discussed, it's also crucial to consider the ethical side of things, to make sure this technology is used responsibly, for the
Yeah,
benefit of everyone.
absolutely. We need to have open and honest conversations about the risks and make sure that QNNs are developed and used ethically. It's not just about the science, it's about shaping a future where technology benefits all of humanity.
That's a great point. So, for our listeners who are eager to learn more, what would you suggest? Where should they go from here?
Stay curious. That's my biggest piece of advice. Read everything you can get your hands on about quantum computing, neural networks, and how they intersect. There are tons of great resources out there. From simple explanations to complex research papers, don't be afraid to jump in and explore.
And you don't need to be a quantum physics whiz to understand this stuff.
Yes. Not at all. This field is going to impact everyone, and the more we all know about it, the better prepared we'll be for whatever the future holds.
Well said. So, to all our listeners out there, thanks for joining us for this deep dive into the fascinating world of quantum neural networks. We hope you've learned a thing or two. And who knows, maybe one of you will make the next big QNN breakthrough.